Professor Mustafa El-Meludi. I'm excited, I'm very honored and pleased to be your instructor for this class. This class is called Discrete Structures. Sometimes they call it Discrete Math. So let me introduce myself. Okay, this is the first week. According to the syllabus, we're not going to be covering that much, so it's going to be kind of short. But I will cover the most important things that you need to be aware of. So in addition to introduction about myself, and maybe we can start the first chapter, or at least a few slides of it, okay? Because based on the syllabus, we're not going to start until next week. But maybe we can get like an overview of what the chapter is about. So let's go over the syllabus. Okay, I'm sorry. Let me introduce myself. As I said, my name is Professor Mustafa El-Meludi. I've been teaching for 22 years, both at the high school and college level. I hold a master's degree in computer information systems from Texas A&M, and then a second master's degree in marketing and international business, and the third one in marketing from Edinburgh Business School, and that's Heriot-Watt University in UK. I've been teaching for 22 years. I taught a variety of courses, many courses. Business computer information systems 1 and 2. I taught all the levels of computer science 1, computer science 2, data structure, programming fundamentals 1, 2, 3, computer organization and architecture, discrete structures, international business. What else? A few more courses. So my background is kind of, as you can tell, is very diversified, very diverse. I like to explore different areas. I don't like to restrict myself. But my computer science is by far my favorite class, because it's not kind of, it's not like other courses that are very limited. It's always evolving. You have to keep yourself updated. So that's what I like about computer science. So I taught computer science most of my time. So this class, so let me go over the syllabus and let's just talk about the most important thing in here. So of course it's an online course. We're going to be meeting every Wednesday, starting at 5 o'clock. This is my email. That's probably the best way to contact me. Okay. So this is the description of the course. We're going to be learning about math, basically, but only the math that is helpful to I'm assuming that most of you took some computer science or of computer science major. So we're going to be focusing on the mathematical structures that are connected to computer science. That's going to help us in other. That's why from time to time, I will be using some programs so we can put into practice what we covered in class. For example, when we talk about recursion, I may use recursion using one of the languages. It would be Java or C++ as an implementation, how we can put it into practice. I think that's going to probably, because the course by itself, some people might find it kind of, I don't know, for some, boring. I don't find it boring. It's very useful. But if you make it fun, it is possible to make it fun. And for me, I think the best way is to connect it to what we do, like in programming and other computer science courses. So from time to time, depending on the subject, I will, switch to, to programming, and then try to implement the concepts we cover in this class. Like, for example, in recursion, when we talk about the algorithm, we're going to be talking about the searching algorithm, linear versus binary search. And then when we talk about sorting, we're going to be talking about the different sorting algorithm, like the merge, like the selection, like the insertion, like the bubble sort. And then we're going to implement them in programming in maybe like Eclipse or any IDE. The same thing for a few others. So whenever we get the opportunity, we're gonna do that. Okay. So that's gonna make it make it a little bit different than the regular courses. So this course, as I said, it presents discrete mathematical structures for computer science and math. And then the topics we're going to be covering logic and methods. We're going to spend probably more than 4 or 5 weeks just talking about logic and logic and proof and also sets. And then we're going to talk about algorithm. Maybe we're going to spend 2 sessions about algorithm. Why the algorithm is important. I'm sure like you heard about algorithm if you took at least one programming language or programming class, you probably talked about the algorithm efficiency. It's not enough to make a program that works, but you have to make sure you make a program that is efficient, that use the least amount of resources. And we'll talk about sets and functions, Boolean algebra, recursion, fundamentals of algorithm, permutation and combinations, and then maybe graphs and trees. So depending on how much time we have, but we're going to be covering basically these important topics. The course is an introduction to discrete structures in math and their application in computer science, with the focus on logic and methods of proof. Now, the thing that you may benefit a lot from this course is it shows you how to prove or how to make arguments, even in your day-to-day life. Sometimes you are in a conversation or you are debate with somebody and you try. How do you make the best, the best arguments? How can you convince someone? How can you make your points? So we're going to be talking about the different ways of proofs, different techniques, different strategies, and that are very helpful in computer science and outside, even in real life. You need a certain way of convincing others. Like how can you make a point? If you feel something, I know, feel very strong about something, but sometimes people they don't know how to convey the message using arguments, using a sequence of reasoning. So we're going to learn some of it from this class. So that's why the first topic, and probably the most important for me, is this area, the proof. The proof area, that's why we're going to spend enough time talking about all the different elements or components of this concept of proof. Acquired knowledge, Boolean algebra, fundamentals of algorithm, permutation and combinations, and few others. The textbook, of course, is Discrete Math and its Application, 8th edition, and then by Rosen. Okay. So this is the breakdown, grading scale. We have 20% are exercises that we do weekly, 20% to show you that you need to spend time, because that's the most important. I want you to practice that. Okay. The quizzes, most of them are multiple choice questions, but you may have some full response questions within the quiz. Like, for example, you may find some of them or most of them are multiple choice, but there are some questions that are full response questions, because that's probably one of the aspects of this course, to show you how to follow the best or the optimal reasoning. So quizzes is 20%, attendance, discussion, participation, all of this 10%, midterm exam, of course, 20%, and final exam is 30%. And finally, this is just kind of the schedule. Week 1, okay. Week 2, week 3. So I think I may have probably to adjust this, because if you go to, hold on. If I go to, let's see here. Let's see. No. Anyways, I think probably there is there is maybe a little bit difference, because I think the first week we, or maybe I'm right. Yeah, yeah, I'm okay. Yeah. Yeah. So the exercise one, I think it's not for the first week. It's until the next week. I'm gonna adjust that. I'm gonna make sure the whatever you have in the syllabus matches exactly what you have in Blackboard. Um, okay, so yeah, so this is the breakdown. So we the schedule week one. So as you can see right here, the first 3 weeks we're going to be talking about chapter one. So chapter one will last for 3 weeks, and then the sets I think for 2 weeks. Again, I'm going to adjust this, and then we're going to talk about the fundamentals of algorithm at least 2 weeks, and so on. So I'm going to make sure that this schedule matches with Blackboard, so there is no confusion. Okay, so I will make sure I do it by hopefully by the weekend. We'll make sure everything is finalized. All right. Any questions? Any concerns? Any thoughts before we get started?
Do we need the book?
Well, the book is important because it has a lot of practice. I don't think the exercises that we give is just to give you the most important thing, but I think the book is extremely useful. There's a lot of practice. There is a lot of exercises, so it's extremely helpful. Extremely helpful. I don't think. Okay, so I know like the PowerPoint slides are helpful too, and then they try to summarize, but the book has a lot of things that the PowerPoint does not have, the practice and explain in detail. So sometimes you may not need it for every single thing, but there are some chapters that you really need like a kind of extensive explanation of a certain topic. Certain topics you may need more practice, and then the book, only the book can do that. Okay, so yeah, that's a good question. All right, so let's go over the first chapter. Even though it was not planned to start, but I'm just going to go over a few slides here about the logic and proof. Okay, so okay, so as you can see here, the logic and proof. So we're going to be spending 3 weeks just talking about this chapter, logic and proof. And this is the different topics we're going to be covering. First, propositional logic. We're going to be talking about what proposition is, what is the definition of proposition, and then we're going to be talking about the truth table, and then the equivalency between two Boolean statements or more, and then we're going to be talking about predicate logic, the quantifiers, um, and logical equivalences. And then this is the third part, is probably the most important part, how to how to make proof. I know if you took probably one of the math class, maybe geometry, I think one of the chapters is about making proof. I think if you remember geometry, the second one where you have, when you have like a problem and then you have to use like a 2-column a proof to basically to explain every single step that you make, like which theorem did you base your answers on. So that's basically an extension of this. Okay. So what is proposition? Proposition is any statement that returns true or false. Anything that returns true or false.
Are you showing something on your screen?
Huh?
Are you showing something on your screen?
Yes, you can see anything?
No.
Oh, okay. I'm sorry. Thank you so much for. I thought like it's already. Oh, okay. So I may have to. Oh yeah. Okay. I think I need to switch here. Okay. I thought like whatever shows in the screen but it looks like this is, yeah. Okay, now, let's see. Oh, okay, this is my better, which is the entire screen. So whatever shows on the screen, it will show. So this is better. Okay. Okay, can you see now?
Yeah.
Okay, so because before I was like selecting like a particular window, so when I change window, that's so you can see it anymore. So okay, as I said, proposition is anything, any statement that returns true or false. And if you think about it, most of the questions we ask on a regular basis in our daily life return true or false. Are you coming tomorrow? Are you going to the game? Did you pass this class? Are you taking this course? The majority of the questions that you ask are either true or false. We call them Boolean logic statements. So proposition is any statement that returns true or false. If it does not return true or false, then it's not a proposition. So this is some of the examples. The moon is made of green cheese. Trenton is the capital of New Jersey. Toronto is the capital of Canada. 1 plus 0 is 1. 0 plus 0 equals 2. So all of these are propositions because you can say either yes or no, true or false. Okay? So either true or false. But sometimes it's not about true or false. Sometimes if somebody asks you, sit down, for example, as it's mentioned here, that's a request. That's not a true or false. Okay? So what time is it? So that's also like a request or a question. So it's not returning true or false. Or if you give your opinion, that's not true or false. So, or sometimes like it's kind of vague. X plus 1, we don't even know what X is. So it cannot be a proposition. We're going to learn later on how we can make this a proposition using other tools. But as they are, X is not defined. We don't know what the value of X is. So therefore, it's not a proposition. So the proposition is any statement, because we're going to be talking only about the propositions, only the statements that return true or false. Anything else, it's out of scope. Okay? And this is basically the tools we're going to be using: negation, conjunctions, disjunction, implication, and biconditional. Okay? So this is like when you combine them, when you combine statements. I'll give you an example, probably that's going to clarify things. Let's say, for example, that talking about exemption, like let's say you are exempt from the final, and there are two conditions. Either you have to have two conditions have to be met for you to be exempt from taking the final, if this is possible. Then you can talk about the grade. You have to have a grade that is higher or equal than 85, for example. And then the absences is less than 3. So now we can combine these two statements. We can use or, for example. So for you to be exempt, you have to have the grade higher or equal than 85, or the number of absences is less than 3. So if you are using or, and the first one is true, do I need to ask the second question? Maybe not. Why do I have to ask? Because that's enough. Because when we say or, if the first one or any one of them is true, then the entire statement is true. So that's basically what we're going to be talking about. Okay? Conjunction, that's and, when you have both at the same time. Disjunction, or, either one. Okay? Implication, that means if something is true, then Q, that implies Q. And then biconditional, it goes both ways. So we're going to have an example for each one of them. So the first one, if we have only one statement, so you have only two possibilities, either true or false. So if a statement is true, then the opposite is false. Okay? Like passing, failing. It has to be one of these. Okay? So P is true, then this symbol is for not. That means the opposite. Basically, it reverses from true to false and vice versa. And then if it's false, it's going to change true. So every time you see this symbol, it changes the value from true to false or from false to true. That's if you have only one. Now, what about if you have two? So if you have two, then how many combinations we can have if you have two? Like, let's go back to the example I mentioned about the exemption. How many possibilities? There are four possibilities, because you may get a grade, you may have a grade higher or equal than 85, and the absences is less than 3. So both of them are true. So that's one possibility. The second possibility, maybe your grade is higher or equal than 85, but the absences is not less than 3. Okay? Now, what's the third possibility? Is if the grade is not higher or equal than 85, but your absences is less than 3. And finally, when both are false, your grade is not higher than 85 or equal, and your absence is not less than or equal than 3. You see, there are 4. There is no more. That's the only 4, because 2, you have true or false, and then you have the number of statements is 2, so 2 squared is 4. Okay? So you have 4 possibilities, and you can see right here. So you can have TT, TF, FT, or FF. So and when you say and, that means both of them have to be true. Again, going back to the example, if the teacher or the professor says the only way you can exempt the final is if you have both of them. Both of them. That means you have to have a grade higher or equal than 85, and your absence should be less or equal than 3. Then if somebody come, let's say ask, and then the grade is maybe 80, does the professor have to check the absences? No, because it says and. If the first one is false, automatically everything is false. That's why I tell my students, whenever you are using and, which one rules? False rules. Because if you have one F, one false, even if you have 5 statements, and you are using and one of them is false, that's going to make everything false. So I tell them, whenever you are using and, false rules. That's why you see, whenever you see F in any one of them, then the result has to be F, even if you have 3, 4, 5 statements. So whenever you have and, so you may use this as a short, it's called short circuit. So sometimes you have, and maybe we can give you an example at the end or later. Sometimes you have like a complicated, like a combination of statements, and they tell you, okay, what is the output of this? Is it true or false? Now, if you have and you can justify or prove that one of them is false, there is no point in wasting your time evaluating the rest, because it's going to be false no matter what. Does everybody understand what I'm talking about here? So when you are using and, false rules, okay? So every time you see F, any one of them, that automatically. So false rules, because you have more F than 2, okay? So that's what and is. Okay, so now this junction is the opposite. We have or. So or is the opposite. Which one rules? True rules. So you have the same combinations: true, 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 false, false, true, false, false. So if it's, since true rules, so every time you say true, you don't even have to check. Going back to the example, if it says the final exemption using or, then if the first condition is true, if I know that my grade is higher or equal than 85, I don't have to check my absences. That's going to be a waste of time, because it says or one of them is enough. And the same thing, if you have 4 or 5 or 6 statements, all of them or, and I can prove that one of them is true, then there is no point in wasting my time evaluating the rest, because it's going to be true no matter what. Okay, so now we have or. This is called XOR. XOR. Why XOR? XOR, that means it's like or, but it's more kind of restrictive. That means they have to be different. You know, sometimes you go to the restaurant and they ask you, you want like salad or let's say salad or soup, but you cannot get both. Okay, you have to get one of them, either salad or. So this is kind of, you cannot have both. You have to get one of them. So this is what XOR. So XOR basically when you have opposite, values, either true with false or false with true, but they should not be the same. Two truths is not going to make it. True false is not going to make it. That's why you have F whenever they are the same. Um, sometimes, like I give you example of the game. Sometimes you have soccer games, and then for you to qualify, you have to win, and the other team has to lose. Some kind of things. If you both win, nobody's going to qualify. If you both lose, you're not going to qualify. This kind of things. Okay, so you have to have a different output. Okay, or outcome. If you are winning, the other one has to lose, or if you are losing, the other one has for one of them to qualify, and something like that. So you can use this example for XOR. Everybody get this? So XOR when you have different values. Okay? So if they are both true or both false, that's false. Implications. So we use this like if you took a programming class, that's basically the if statement. We can call them, sometimes we call them conditional statement. I think that's what it says right here. Conditional statement. Okay? So if the condition is true, then it should imply Q. Okay? If, for example, if your grade is higher or equal than 70, then you pass the class, which means if the first one is true, then the second one, then the conclusion should be true. Now here, you need to, there's a little tricky situation here. Most of them all make sense. If it's true, true. If it's true, false. If it's false, true. So how can we explain this? Okay, I think all of them make sense except this one, the second one. If the first one, look, everything true except the second one. And I'm going to give two examples because some students may have hard times understanding this. So I'm going to give the two examples to kind of simplify this. Let's say, for example, that a politician, for example, he wants to be elected, okay? And then he made a promise that, okay, I'm going to do this for you. I'm going to build a bridge, or I'm going to give you a paycheck, return 2,000, whatever he says. So if he gets elected, then you expect him to do his promise. So that makes sense too, okay? Now I'm going to skip the second one. If he was not elected, F, and then he may be able to do it, but maybe he has money or has power, he has authority, he can still make that bridge and then still true. Now, if he was not elected and he didn't do what he promised, nobody's going to blame him, right? Because he did not get elected. He said, if I was elected. But look at the second one. If he was elected and then he did not make that bridge, he did not build it, he did not do what he said he would do, then that's going to be disappointment. That's why it's F. That's probably an easy way to understand this. Okay? That would be disappointment because he promised something and he did not do it. So anyway, sometimes you just have to memorize this. But just remember that everything is true for the implication except this case. If the condition of P is true and then Q is false, that's the only one that's going to give you false for the implication. Okay? All right. Understanding implications. So we'll talk about this. I think probably if you took programming class, then the if statements probably that should make sense to you. So this is just different way of basically expressing or paraphrasing this statement. Sometimes we say if P then Q, P implies Q, P only if Q, and all of this are probably means the same thing, implication. Now we're going to talk about the converse, transpositive, and inverse. If you took geometry class, that these terms should be familiar to you in high school. So as you can see here, the converse is basically when you switch them. Like for example, if I get a grade higher or equal than 85, then I pass the class. Okay, so the converse is if I pass the class, then I have a grade higher or equal than 85. That's what the converse is. Contrapositive is when you switch them, but you negate them too. Like using the same example, if I don't pass the class, then I did not get a grade higher or equal than 70, or whatever the grade is. See, you switch them, which means the conclusion will become the hypothesis, and the hypothesis becomes the conclusion. And the inverse, you keep them as they are, but you negate them. If I don't get a grade higher or equal than 70, then I don't pass the class. So this is what converse and contrapositive and inverse is. Okay. Now biconditional, it goes both ways. That's why you see the two arrows right here. The implication goes only in one direction from P to Q. That means for you to prove this, you have to go both ways. You have to go from P to Q and from Q to P, which means basically they have to be either both true or both false. That's the only way you can get this one true. Both of them have to be the same. Okay? Remember XOR, they have to be different. Here's the opposite. They have to be the same to have true. That means, okay, if I get a grade higher or equal than 70, then I pass the class. And if I pass the class, then I get, or I got a grade higher or equal than 70. Okay. So this is like a different way of expressing the biconditional. All right. So now let's use that. This is an example of using the truth table. So let's use this one, see how we got this, because we may get questions about this. So how can we use the truth table to see the output of this statement? So P or Q implies not R. So you start with P and Q and R. Now, how can I come up with this? Because we are not used to 3. We are used to 2. We have 4. Now, how many we have here? We have 8. The first one, why do we have 8? How can I, where does 8 come from? Maybe we missed something, a combination. Remember, like when we have 2 statements and true and false, that's 2 squared. But when you have 3 statements, you 2 cubed, that's 8. Now I'm going to show you an easy way to remember this combination, because there are many of them, right? 8. How can you remember them? The easy way to remember them, look at P. We have 4 T's, 4 F's. Look at Q, T, T, F, F, T, T, F, F. And what about R? You alternate, T, F, T, F, T, F. I think that's the best way. Otherwise, if you try to remember them as all the 3, that's going to be difficult, because it's possible you may miss someone. But if you use this technique, 4, doesn't matter the order, okay? You can put this P in the middle, doesn't matter. So 4 T's, 4 F. T, T, F, F, T, T, F, F. And then you alternate T, F, T, F, T, F, T, F. Now we're going to start with, here it doesn't matter. You can start with first one or second one. But since we have an implication, then we need to start with the first one. So P, OR. What did we say about OR? Which one rules? The true rules. So you're going to have more T than F. So as you can see here, P and Q, every time you see T, don't even look at the other one. So 4 T's, definitely you're going to have 4 T's. Now look at the second one, T, T, only the last 2 are F. So that's going to put all T's except the last 2. Okay. Now let's look at not R. Not R, basically the opposite of R. So every time you see T, change it to F. If it's F, change it to T. Now implication. What did we say about the implication? The only time you're going to have false if the condition is true but Q. If P is true and Q is F, which means basically, so we're gonna basically that's why I think it's better to have this column before this one. So can you see like F here? Because TF, this is the condition, and then F. So that's the only time you're gonna have false is if the first one, because remember this is P or Q, this is the condition here. So that we're going to start from there. If it is true and then not R is false, then that's the only time I'm going to have. All the other cases, TT, again, TF is false. TF is false, FF is true, everything is except this. So that's why we have this output right. Okay, so remember, whenever you have an implication, the only time you're going to have false is if P is true and Q is false. Equivalent propositions. How do we know? What does equivalent mean? Equivalent doesn't mean the same. It means they generate the same output, which means if the output, for example, let's say we are comparing two statements, two Boolean statements. If they generate the same output, let's say 40 to F and the other ones has exactly the same, then we call them equivalent. That means they are equivalent because they generate the same output. Okay, so two propositions are equivalent if they always have the same truth table, truth value. Okay, so as you can see right here, these two are equivalent. T, F, T, T. Now, if you look at the first one, P implies Q, but look at the other one. Is it the converse, inverse, or contrapositive? So this is something you can use because contrapositive, the statement and the contrapositive are equivalent, and this is proven by the truth table. So this is contrapositive. When you switch them and then you negate them, remember we did that in the previous slide. So when you negate, so P becomes Q and Q becomes P, and then you negate them, this is the contrapositive. So that shows that the contrapositive and the statement and the contrapositive are equivalent. That's another example. Using the truth table to show no equivalence. So here we have P imply Q, and then here we have that this is the inverse. So here we have the inverse. So the inverse is not equivalent. Contrapositive is, but the inverse no. If it is not, okay, using the example, if my grade is not higher or equal than 70, then I'm sorry here, not P. If P is negative, it does not. The inverse is not equivalent. That means you're not going to generate the same output in here as shown in the table. Okay. Okay, precedent. This is also very important. Precedence, that means if you have all of them, if they're combined, which one you start first? Of course, not has the highest priority in a combination. And then and, then or. Does anybody have an idea why and has the highest priority than or? Why? Anybody has any idea why? And so if you have two statements, if you have a statement that combines, and you should start, especially if you don't have the parentheses, because the parentheses has the highest priority, right? But if you don't, then which one has the highest priority is and. You know why? Because and kind of represent the multiplication and, remember? And or represent the addition. And according to the order of operation, which one comes first, and or? I'm sorry, multiplication or addition? Definitely multiplication comes first. So that's why. So it has highest priority. Then implication, then finally by conditional. So remember this sequence in case you have to start with one. Okay, and then we talk about the translating English sentences. So how do we convert like two statements? Because usually when you have two statements, you assign them to variables. Like for example, P, let P equal, for example, my grade is higher or equal than 70. You can. Okay. That's how we're going to translate into English sentences. And then let Q be I passed the class, for example. So how do we translate? So this section is about how to convert mathematical Boolean equations or Boolean statements into English sentences. Let's see if you have an example here. Yeah, all of these are examples. So here, P is I go to Harry's. Q, I go to the country. And then R, I will go to the shopping. So of course, if you want to negate, you just have to go, I will not go. I will not go. Or it's not the case that I go to. Okay? So, so that's how we translate to English sentence. I give you some example. We may go to over the exercise and can explain it even more. Okay? So for example, here A, so you have to, first one, you have to define your variables. Let A, C, and F represent each one of them. Okay? For example, A, you can access the internet from campus. C is you are a computer science major. And then F, you are a freshman. So how can we translate this statement? So A, you can access the internet from campus implies you are a computer science major or you are not. Look, opposite. You are not a freshman. That's what it means. So you can access the internet from campus implies that you are, so either or, you are either computer science major or you are not. Look, it's not the case that you are freshman. So it's easy to translate to English sentences. Once you have two examples, that becomes easy. Let's talk about the logic. I'm going to end with this, logic circuits. It's just an easy way to combine statements. Okay, so you need to be familiar with the symbols. The first one is not. Every time you see this triangle, then you are basically negating that statement, as you can see here, P. So once you use this triangle, it becomes not P. Now look at the second one. The second one, the curvy one. The curvy one, I'm talking about the base. It has the base curved. So this is OR. So we have P or Q. But look at the third one. It's straight base. So this is AND. So when you combine them, like for example, look at the example here. So what do we have? We have P, and you can tell that Q is negated. So P and, because the base is straight, it's not curved. So P and not Q. And then look at this symbol, or not R, because we have the triangle. So that's how we use the logic circuit. All right. So we're going to stop here. Let me go over the exercise and see if we have any questions about the exercise. See here. Let me open a new one. And see what the exercise is about. I know some of you already started working on it. It's not bad. So what is the exercise? It should be, again, it should be in week number 2. Okay, exercise number 1. Guys, can you see the screen?
Yeah.
Oh, okay, thank you. So this is, as you can see, right, this is the same exercise. It's just one in the Microsoft Word, and then another one, another version, another format in PDF. I know some people, they like Microsoft Word version, others, so I decide to put both. So what is the exercise 1 about? I just want to explain what the question is asking. It's exactly what we talked about in this meeting, in this virtual meeting. So the first one, basically, what is the proposition? We said anything that returns true or false is a proposition. Okay, so I have A, B, C, D, E. Basically, you need to highlight or circle, it says circle the right answer, which one return true or false? Okay, we talked about this. Number two. So number two, we talked about the truth table, right? So we said P, when you have two, it's T, 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 F, F, T, F, F, and then you try to find the OR first. Remember, whenever you have OR, true rules, okay? The only time you're gonna have false if it is both of them are false, if you are using OR. And then once you find that column, then negate everything you have. If you have T, change it to F. If you have F, change it to T. And do the same thing with the second one, third one. Remember the third one, you need to find the first part. Remember, it's biconditional. What did we say about biconditional? They have to have the same value. Either both are true or both are false to be true. Everything else is false. Okay? And for number four, this is XOR. Can you see this plus inside the circle? So this XOR, what is XOR? XOR, they have to be different values. They have to have different values, TF or FT, for you to get true. Otherwise, it's false. So, but you have to negate Q, right? It's negating Q. Then use XOR. And this is equivalent. What is about equivalent? Equivalent means they have the same table. They have the same truth value. So you're going to use the one on the left side and then P and compare them. If they have the same output, the same outcome, then they are equivalent. Sometimes you can use common sense, okay? Like for example, the first one here, you can tell that P has the upper hand. Look, P and P or Q. That means the output depends on P. So you can use the law of absorption because it's like a P is absorbing Q, but you don't have to. You don't have to know this. You can just use the truth table. But I'm saying there's some shortcuts. You can tell if they are equivalent because P, the output will decide by P. If P is true, then it's going to make everything true. If it's false, then everything is false. Okay? Oh, but here it says use truth table because I want you to be familiar with the truth table. I want you to get enough practice. So all of them, so you're going to have both of them and then compare the answer. If they have the same output, then they are equivalent. Okay, number four. So here you need to express this in an English sentence. P, what is P? A number is even. So you're going to put a number is even or a number is divisible by 2. Okay. Number two, you're just going to focus on P. You're going to say the number is not even, or it's not the case that the number is even. Number three, implication. If the number is even, then or implies a number is divisible by 2, and so on and so forth. So you're doing the same thing. Number six, say the number is not even because you are negating, and a number is not divisible by 2. Okay, and then finish the same thing for the rest. Okay. Number five, the converse. What did we say? The converse, contrapositive, and inverse. Okay. So the converse, you switch them. Contrapositive, you switch them and you negate them. And the inverse, you just negate the inverse. Okay, and then finally with the one that we talked about, the combinatorial circuits. So we said that the triangle is for not, and then the one that has a straight straight base, that's and the one that has curly or curved line as a base, so that's or. So you can tell that it is here. We have and, so P and not Q. And then here you're going to use or, not R, and so on. Okay? Any questions? So this is what exercise one, as you can see, is very simple, very easy. You should have no problem with that one. Any questions? Okay, so if you have no questions, I'm gonna stop the recording.